Hello, this is Dr. Hans. Welcome to Review Materials for Real Estate. While people are getting started here, I just want to make sure that everybody's audio is on. So turn your audio on and make sure it's at an appropriate level. And also, I want to remind everybody that these are WMV clips, okay, or WMV files. And hopefully you just were able to click on the links to these files and they would start up automatically in your media player. However, if you're having trouble with these links, you might want to download them onto your computer. And to do that, you just right click on the link, and when you right click, a menu should appear, and you want to select the item Save Target As. And what you can do is then save the file to your desktop or anywhere else on your computer, and then go directly to that file and click on the file. And hopefully, again, your media player will boot up, and you'll be able to see this clip, both video and audio. This is the introduction to a series of clips. So what I've decided to do is not make one big long clip, but make a series of shorter clips, and that way you can go to different sections and jump around if you prefer to, or go back to certain sections. What we'll cover in this clip, here's our table of contents, and I'm going to try to write with a mouse pen, and I have a lot of respect for people who can write with a mouse pen because it's a lot tougher than it looks. But here's roughly what we're going to be going over in roughly the order. This isn't exactly the order that we're going to go, but this is, again, a short introductory clip, and we'll go over the concepts of time value of money. The purpose of this review packet is basically to get students, real estate students, up to speed in any real estate course that they're taking. And this goes for both undergraduate and graduate real estate students. So what I hope is that you can view these clips, and for many of you, especially the graduate students, this might be more of a review or a refresher. For undergraduates, this might be the first time you're dealing with these concepts. But all these concepts are extremely important in my opinion. In fact, probably the most important thing as part of your business education. So, whether it's review or for the first time, I hope these clips do help you. We'll be talking about the different time value of money functions. And also, what I suggest that you do is you print out this packet, make a hard copy, and take notes along the way as we go. I'll be scribbling on this packet as we proceed. You also probably want to have your calculator handy and ready to go. And if you're still looking for different types of calculators, or considering different types of calculators, I've created a clip to talk about a couple different types of calculators, and I encourage you to view that clip first before you proceed. So we'll be talking about present value, future value, present value, future value of annuities, mortgage payments, sinking fund factors, and all the functions of time value of money. We'll also spend a little bit of time on loan balances, which is pretty important to real estate, and also discuss discount points. I also included the concept of duration, and I understand that probably for most of the courses that you're using these clips for, you might not even touch upon duration. But duration is a pretty important concept, whether you need to know it this semester or not. But I will go quickly through this concept. And also we'll talk a little bit about variance in real estate cash flows, and we'll look at an amortization schedule, or a loan paydown or payoff schedule for a fully amortizing loan. And at the end of this packet, and this is about a 27-page packet, there are 4 problem sets. Now, again, what I hope that you do is you print out the problem sets and you try the problems before we go over them, but I'll have a clip for each of the problem sets going over the answers to each of the problems. The problem sets start out fairly easy, so problem set number 1 is pretty easy, number 2 gets a little bit harder, number 3 is a little bit harder, and 4 is probably the hardest. So it increases in difficulty as you proceed through the problem sets. But again, I think the best approach to the problem sets would be to try them first, and then go to the video clips to basically check your answers, hopefully. Now, in the older days, when we covered time value of money, we used to use factor tables. And this is an example of a factor table. We also used to use formulas. And nowadays the calculator has replaced both the factor tables and the formulas. However, in this packet, one of the things I like about this packet is that they do present the formulas for each concepts, because I think the formulas are still important, although you're probably not going to be using them on exams, most of you. Occasionally I do get some students, usually with some kind of technical background, maybe former engineers or, former math majors. They love the formulas and they learn, the concepts very quickly and well from the formulas. So I'm going to present the formulas. Probably for most exams you don't need to know the formulas, but it's good at least to see them. And this is a compound. This is a compound or a time value of money table, interest factor table. And we used to have tables for each interest factor, okay? And this is an example of the time value of money factors for a 10% interest rate. And you can see we have 6 different columns, not including the year. And each of these columns are a different time value of money function. The first one has to do with compounding. Okay, so the first column is compounding. And that's a extremely important concept we'll be talking about a little bit more. And it's basically if you invest $1 at 10%, per year into some account for 10% per year, how much money will you have each year going forward? So if I invest $1 today, okay, that would be year 0. Okay, today I'll have $1. At the end of the year, I'll have $1.10. And at the end of the second year, I'll have $1.21, and in the third year, I'll have $1.33, and so on. If I leave that dollar in that account for 20 years, at the end of 20 years, I can expect to have $6.72, almost 73 cents, which is down at the bottom of the column. Okay. How did we get these factors? Well, they come from the formulas. So basically the tables, who created the tables, someone sat down with the formulas for these different concepts and crunched the numbers and put them into tables. But again, nowadays we use calculators to do this. But the formula for a future value factor is to calculate the future value at a given interest rate, which is 10% for a given number of periods, which we represent the number of periods as n. So when we talk about I is the interest rate, and that's 10% or 0.10. And when we talk about n, it's the number of periods. In this case, our periods happen to be years. Don't think of n as number of years. That, in my opinion, is a mistake, because we're not always dealing with years. When we talk about mortgages are usually, you're dealing with monthly payments, so your periods are, the term that your periods in that case are months, not years. So think of n as number of periods, not necessarily always number of years. So if future value equals the present value times 1 plus I to the nth power. So basically for this first column here, someone took this formula at a 10% interest rate. Okay, and for each year, for each n, they calculated the present value factor using this formula. So they plugged in 1 into PV, and then they calculated a factor based on 1 plus I to the nth power. And you should know how to raise something to the nth power, or to any power. And basically, again, this is a little function on the calculator. On my HP calculator, it's the key, the y to the x. On some other calculators, it might be a caret or a hat. So for the power function on your calculator, just look for either y to the x or maybe a caret symbol, a little hat there. And why don't you go ahead and recalculate or recreate some of these compounding factors. For example, you could take 5. So take 5, put it into n, plug in 0.10 for the interest rate. Okay, the interest rate is expressed as a decimal. Okay, so you don't put in 10%. percent or 10, you put in 0.10 as a decimal format. And for PV, put in 1. And what you should come up with is very close to that present value factor, compounding factor of 1.6105. Also notice on this table, these tables are nice to look at also because you can see what happens with compounding over time. You'll notice that if you go from years 1 to 10, the dollar increases by about over 2.5%. But if you go from years 11 to 6, the compounding factor increases at an increasing rate. And that's a very important characteristic of compounding, that compound interest increases at an increasing rate over time as you expand or extend the number of periods. And that's the basis of the advice that you might get to start investing early. If you start investing early, what you hope to do is have a long number of ends, okay, a long number of periods, and hopefully you can compound your investment and earn interest on your interest and interest on your principal, and that's going to increase at an increasing rate over time. So that's another very useful thing about these tables, is that you can see how the factors change over long periods of time. The next column here is the present value of $1 per period. Okay, so this column we could abbreviate it as future value of a lump sum. Okay, so that's FVLS. Again, sorry about my mouse pen writing here. The next column is the future value of an annuity, and I'll abbreviate that ANN, future FVANN, future value of an annuity. And what an annuity is, it's the same payment per period for more than one period. So it could be $1 a period for 20 years. And that's exactly what this table is what if we invested $1 per year into an account earning 10% for 20 years? And this would be our factors for $1 invested each year. I'm not going to try to write the formula for the future value of an annuity with my mouse pen here, because I barely got the simpler formula written for the future value of a lump sum, but it's going to be forthcoming in our notes here. The next column, okay, the third column is the sinking fund factor. And a sinking fund is something like a Christmas account. A Christmas account, what you do is you start investing in January, you put a little bit away each month, so that by the end of the year, you have a nice, you've accumulated some money to buy Christmas gifts for your family or for everybody. And that's the basic concept behind a sinking fund. Our sinking fund in this example is going to earn 10% interest. So whatever we invest, we're going to be making interest on our investments per period. But we're going to put some money away, an equal amount away each period, so we can accumulate a certain amount by some future point in time. And that's a sinking fund. The next column, this is the present value of $1, or the PV of a lump sum. This is also known as discounting, which is a very important concept. With discounting, we have some future value that we know the amount of, and what we want to do is we want to convert it to today's dollars. We want to discount it to present value. It's kind of the opposite of compounding. And remember, this was compounding over here in the first column, where compounding is the opposite, because we have some present value today, and we want to know what the amount's going to be at some future point in time. So we want to take the present, convert it to the future. With discounting, it's just the opposite. We take the future and convert it to the present. And this is almost like an exchange rate for time. You have an exchange rate between dollars and yens, or dollars and euros, and because those are two different units of currency. Well, you can think of dollars over time are really in different units of currency. And what we're doing with discounting is taking some future dollars, which are a different currency, and converting them to today's dollars using discount factors and discount rates. And this table shows us the discount factors for a dollar for each period over 20 years. The formula for these factors is pretty simple, so I'm going to try to write it here again. It's just the formula that we started out with, but we're going to manipulate it algebraically to solve for PV. So PV at a certain I and a certain N is the FV, the future value, divided by 1 plus I, looks like a J, but believe me, it's an I, to the nth power. And basically, again, this is simply what this table is. It's someone sat down, and for a 10% interest rate, they calculated the present value factors for each period over a 20-year period. And again, what I suggest that you do is recalculate or recreate some of these factors. For example, take 15 years, or n equals 15. Plug it into the formula. Don't forget I is 0.1. And you should come up with 0.2393. And what this factor means is that someone should be indifferent. If their discount rate is exactly 10%, that means someone should be indifferent between accepting 24 cents today and $1 15 years from now. Okay, so that's what this factor tells me, is that added 10% discount rate, if someone's discount rate is exactly 10%, if they had a choice between $1 15 years from now and almost 24 cents today, they'd be indifferent. Okay, if you'd offer them 50 cents today or $1 15 years from now, they take the 50 cents today, definitely, rather than wait 15 years for that dollar. And this better than anything reflects the time value of money. That money has value, extra value today, and because of inflation and risk and other things, it deteriorates over time. So if you ask me, would I want $1 today or $1 15 years from now, I would say I would take that dollar today. There'd be no question about it. If I had that dollar today, I could invest it and make money off of that dollar. If I had that dollar today, I could spend it, I could consume it, and that has utility. So one of the basic tenets of finance is that you prefer to have money today rather than some point in the future, because of the time value of money, because of risk. And $1 today is worth more than $1 sometime in the future. And these discount factors just are again kind of the exchange rate between future dollars and present dollars. Looking at the 20-year discount factor, okay, you can see in 20 years, if your discount rate is truly 10%, you'd be indifferent between 14, almost 15 cents, today, and $1 20 years from now. And again, if someone offered you 20 cents today, or $1 20 years, from now, your discount rate was truly 10%, you'd take that 20 cents up front right away every time. If someone offered you 5 cents, okay, today, or 14, 15 cents 20 years from now, you take the latter deal. You take the 14, 15 cents 20 years from now, if your discount rate was truly 10%. Now the next column is the present value of an annuity. So we'll abbreviate that PAANN, present value of annuity. And here what we're doing is we have some annuity, okay, again, a constant payment over a period of time, over equal periods of time. For example, in this, it's $1. For this factor, it's $1 a year for 5 years. And what we're doing with the present value of annuity factors is we're discounting that annuity back to present value. Okay, and again, this table assumes the 10% discount rate. Then the final column is installment to amortize $1. And this might be more commonly referred to as the mortgage constant. okay, especially in real estate, because this is how we calculate mortgage payments. Or you can think of this as a mortgage of $1 and what the payments would be for different terms, for different periods, different years in this case, for the payment of a mortgage that's in the amount of $1. And again, this is very important stuff for any real estate class, for finance, investments, fundamentals, analysis. You're definitely going to have to know how to calculate a mortgage payment. So if we took out a mortgage of $1 and had a 20-year period and it had annual payments, our mortgage payment would be 11, almost 13 cents per year for 20 years. And the mortgage constant represents two components. It represents return of investment and return on investment. The return on the investment is the interest to the lender, okay, the interest portion of the payment. But the mortgage constant also, in a fully amortizing mortgage, there's a component of principal repayment or amortization, principal reduction. Because with each of your payments in a fully amortizing mortgage, you're paying off that mortgage. And at the very end of your mortgage, if it's a 20-year mortgage, with your last payment, you pay off that mortgage in full. So the mortgage constant is also loaded for amortization or mortgage reduction, reducing the principal with each of the mortgage payments. What we'll do towards the end of our material here is we'll look at an amortization table. And what an amortization table does is it breaks up the mortgage payment or the mortgage constant into its two components, principal and interest. Okay, well, let's move on. Again, we're not going to be working in tables or formulas, although I'm going to show you the formulas for each of the concepts here. But the first concept that we're looking at is compound interest. Compound interest, and this is extremely important because this is why people who have money stay rich, and people who have debts have trouble getting out from underneath debts, because compound interest can work for you if you have investments and it's basically your money making money for you. If you don't have investments and you have debts, credit card bills, compound interest could work against you, and it's very hard to catch up with compound interest. Well, the first example here, again, we're going to use a nice round 10% compounding rate. And in the first example, we're going to look at a calculation of interest without compounding. Okay, so the first example here is no compounding. And with no compounding, we just have we start out with a principal amount of $1,000. And again, if we put this in account for a full year and the account's earning 10%, okay, we'll generate $100 interest. So our ending balance is 1,100. Now, our new balance, okay, for the next period is 1,100. But again, if we only have interest on our principal, okay, so if we're only calculating interest on our principal, not our principal plus our compound interest, okay, we still just make $100 for that period because it's still 10% of the original $1,000. And at the end of the period, we have $1,200. And then for the next period, okay, we start out with a beginning balance of 1,200. Again, we got a bad account here. We only make interest on our original principal, so we make another $100 interest. So our ending balance is 1,300, and so on for 2 more periods, until after 5 years of investing in this investment, which on the surface is 10%, that sounds like a good investment. But we read the fine print here, and it's only 10% on our original principal. We'll have $1,500. Well, let's compare this to an investment with compounding. Okay, so the second investment is more typical of lots of investments. Okay, and this time we have compounding. And you can see we start out still with $1,000. and it's a 10% account. So the first period we still have our 1,100, but the second period we're making 10% on our principal and our interest this time. So the second period we just don't make another $100, we make $110 because it's 10% of 1,100. So at the end of the second period, where originally we had 1,200, now we have $1,210. We have an extra $10. And that extra $10 represents compound interest, which is interest on previous interest. And that's what's so important about compound interest. This example is a little bit short in terms of terms. It's only a 5-year example, so there's not going to be a tremendous difference between the numbers that we're going to get to here in a second. But compound interest can be very powerful, especially over longer compounding periods. In fact, someone asked Albert Einstein once, what's the most important discovery, or force out there? And he must have been working on his retirement plan or his balancing his checkbook, because he answered compound interest. Okay, everybody thought he was going to say the theory of relativity or black holes and something like this, but he said without hesitation, the key to the universe, especially the financial universe, is compound interest. It's very powerful once it gets going, though. So you can see the next period. Now we're starting out with a beginning balance of 1,210, an extra $10 over the non-compounding example. And so we have a 10% interest on the 1,210, which gives us $121. Okay, and in the prior example, we only had $100. Now we're making an extra $21, which gives us an ending balance of 1,331, which now is $31 higher than our no compounding example. So for year 4, we have a balance of 1,331. 10% return on that gives us an additional $133.10, which gives us an ending balance of $1,646.10. So this compounding is starting to pick up momentum, starting to pick up speed, this concept of making interest on your interest. The 5th period, we have a beginning balance of $1,464.10. We make a full 10% return on that total balance. That gives us interest and compound interest of $146.41, which gives us an ending balance of $1,610.51, over $110 more than our ending balance in our no compounding example, 1,500. So that's the beauty of compound interest. That's the power of compound interest. And again, if we continue this example 10, 20, 30 years, the difference between the no compounding and the compounding example is just going to grow exponentially. It'll be huge. So again, that's why people tell you to start your, it doesn't matter how much you start with, okay? Start as early as possible, because the sooner you start your investing, the sooner you can put compound interest to work for you. So the key with compound interest, when interest has been earned, it becomes principal for the next compounding period, and you make interest on your prior period's interest. Now, this book kind of refers to the 5 variables that are used to make compound interest calculations, and that's correct. I think we might refer to these calculations, also or more as the time value of money calculations. Okay, so when we talk about the compound interest calculations, I might use the term or the concept of the time value of money calculations. Sorry about the sloppy handwriting there. Interchangeably. And basically, whenever we're talking about the time value of money calculations, I also like to think about this visually. I think about our calculator and that time value of money menu on our calculator. So if you're watching this clip, hopefully already you've found the financial calculator that you want to use, whether it's an HP or a TI, and you're becoming familiar with that calculator. And one of the most important menus on that calculator is the time value of money menu, and that's the N the interest percentage per year, the PV for present value, the PMT for payment. Okay, that's not RMT, that's PMT, and the future value. Okay, that menu, that's the time value of money menu that we'll be using for most of our time value money calculations. And again, the way you can think about some of these problems that we're going to be looking at, especially in the problem sets and throughout the examples in the next couple of sections, is that if I know, okay, any three variables, if I'm given n, if I'm giving I, if I'm getting PMT, I can solve for present value or future value. If I'm giving n and I and PV, I can solve for future value or payment. So basically, it's kind of like a puzzle. And if you put in three pieces of the puzzle, you can always find the fourth piece of the puzzle, solve for the fourth piece. So that's how kind of how I think about these problems a little bit. And they're actually, you know, I know at first it doesn't sound like it's going to be fun, but actually once you get the hang of it, it can be a lot of fun too. In our first example here, all right, we have a deposit in a savings account that pays 10% interest compounded annually. How much will you have on deposit at the end of 3 years? And this is kind of the format of this packet for all the different concepts of time value of money. It gives a problem, gives an example. It also gives the calculator keystrokes, okay, although I recommend whenever you face a problem, okay, you don't do it with the calculator first, you write out the problem as it would appear in your calculator's time value of money menu. Okay, just write this little time value of money menu quickly. And what you do is you read the problem first, and you figure out what you're solving for. And in this problem, we're asked how much will you have on deposit at the end of 3 years. So that tells me that I'm dealing with some future value, okay, some future time, some future period in time. So what I do next is I put a box in the key or the register that I'm solving for to remind me this is a future value problem. Sometimes I even write the type of problem out to the side here, future value, and it's going to be a future value of a lump sum. Okay, because I deposit 500 in the savings account, and I can even add the word today there, which is our keyword buzzword for present value. In fact, that's what I'll enter next. Okay, so I'm going to put 500 into PV. Account that pays 10% interest compounded annually. Okay, so 10 is going to be my interest rate. And this is one of the things you'll have to check in your calculator. Most of the calculators that I've come across ask for the interest as a percent. So when we did some of the formulas, we were talking about some of the formulas we put the interest rate as a decimal point, 0.10. But in most calculators, and I found some exceptions to this rule, but most of our calculators, 90% of them, ask for the interest rate as a percentage. So I'll put in 10, not 0.1. If your calculator asks for the interest rate as a decimal, you would put in 0.1. But my calculator, the HPs, I think the TIs too, ask for it as a percentage. And then N is the number of periods, and the number of periods is 3. And something we're going to have to watch here very carefully is that N and I have to be consistent all the time in terms of the number of periods. Because what I'm recommending that you do, okay, is make sure that your calculator is always set on one payment per year. In the calculator clip, I talked about this concept and asked that whatever calculator that you're using, you should know how to set the payments per year. And what I'm suggesting to everyone is that you set your calculator on one payment per year, and you leave it on one payment per year. When you have a problem that doesn't have one payment per year, you can make an adjustment yourself on the interest rate to make the interest rate periods in n, whatever that unit of n is, comparable or match each other. So take the time now to make sure your calculator is set on 1 payment per year. Also, you want to double check to make sure your calculator is set on end mode as opposed to begin mode. Okay, if your calculator is set on begin mode, you might see somewhere in the screen BGN or BEG. And I talked about begin mode versus end mode in the calculator clip also. Begin mode simply assumes that the cash flows are coming at the beginning of each period, and end mode assumes that the cash flows are coming in at the end of each period. We usually want our calculator set on end mode, so I suggest you set that to end mode by default also. Although there might be occasions where you might switch it to begin mode, but it's relatively rare. Okay, so now that you've identified the problem, okay, and basically what we've done, we've just rewritten, this out to look more like, vertically, more like our calculator time value of money register. So now you're ready. Well, one more thing you might do, you might check your payment key, okay, your payment register, and make sure that's empty or 0. In fact, what you can do is you can put 0 in there to make sure it's 0. Another thing that causes problems with calculators is that you do one problem, and if you don't clear your registers totally out, there might be something left over in one of the registers from a previous problem, and that's obviously going to affect your answer to the current problem. So something else that you should get in the habit of doing when you approach a problem like this is to first clear your register. All right, check your calculator, make sure it's set on 1 payment per year, also in end mode, and also learn how to clear your register. And this is trickier than it sounds because calculators usually have 2 clear buttons, and one clear button is just to clear the screen, or what you see visually on the screen. It doesn't clear anything within the calculator, any of the calculator registers. So usually there's a second button where you can clear the data or clear out the registers. And what you want to do is you want to clear out the registers. Or as a backup, you could make sure 0 is in there by putting in 0. But once you have this set up, go ahead and hit future value, and your calculator should come up with our answer here of $665.50. Now, how did the calculator do this or get this? Well, it made this calculation that you see below here. So this packet also shows you, when possible at least, kind of the manual calculations that are used to calculate, the step-by-step. So what we had, again, going back to the problem, we invested $500 for 3 years. Okay, and this is how it grows each year. If it truly is an account that earns or generates 10% compounded annually. So the first year, we make a 10% return or $50, add that back to the principal. So at the end of the first year, we have $550. The second year, we're making 10% interest on $550, so that's $55 or $50 of interest and $5 of compound interest. Added back to the principal of $550, that gives us $605. And then the third year, we start out with $605. Over the course of the year, we earn 10%, or $60.50. Add that to the beginning balance of $605, and that gives us $665.50. Okay, so that's how we we calculate basically compound interest. And you can see doing it this way gets a little bit tedious. So that's why we use the calculators, and we can quickly calculate compound or future values, just by changing n. 20, 30 years, doesn't matter. The calculator can crunch that out very quickly. Our next concept is the future value of a lump sum. And what I'm going to do is I'm going to stop the clip here and start a second clip, starting out with the future value of a lump sum. Signing off for now. See you at the next clip.